So we'll talk about first the model tab, SAM and all that. But anyway, I mean, like, I'll just give you quick introduction because all these things we'll be seeing later. Okay, all these things are separate topics later. So see, model tab is the most important tab for a developer because pretty much all the things that comes under development are in here. Okay, and the most important place is the schema is the place where you do all the development activity. Okay, so most of the development activity will be done in the schema. For example, creation of the base object, the landing table, the staging table, then the match and merge configuration, validation rules, relationships, lot of things, columns configuration. You will see that many things you need to do it in here. The schema viewer is just a read-only thing which just shows you how the schema looks like. So moreover, like a data model, it shows you. Okay, and then systems and trust, which shows you the trust configurations. So per base object and per column, what is the score and all that you have configured. So on this column, what is the score? This column, what is the trust? Okay, that's what you can see. Queries is nothing but it's just a query. So select star from EMP. That's a query, right? So it's also it's the same thing here. Queries. So which you can use to view the data. Like if data is there, you will see the data here. Packages is nothing but view. So you know database views. You would have seen database views. So just 1 minute. 1 minute. Okay. Packages, like you know what is a view, so it's the same thing here. So whatever you call it as view in database, now that is nothing but a package in here, MDM. Okay, and cleanse function is mapping, and cleanse function are related. Mapping is a feature. It's something that loads data from the landing table to the staging table. That's what it does, landing to the staging table, right? Now when you want to load data from the landing table to the staging table, you might want to transform something. Okay, you might want to do some standardization or address validation or enrichment, cleansing, anything. So if you want to do that, then you have to use the cleanse functions. So cleanse functions are equivalent to what you have in ETLs, what you have as transformations like expression, router rank, those kind of thing. So that's the equivalent of this. That's the cleanse functions, right? And hierarchies, this is used to design the hierarchy. Design the hierarchy in the sense. Now what exactly is hierarchy? Hierarchy means, see, you will see that wherever you go, anywhere in the world, you will see hierarchy. So in your family, you have a hierarchy. You have son, then reports to father, then father, grandfather, great-grandfather, like that. That's the family hierarchy, right? If you go to a company, then you have employee, manager, like employee, team lead, manager, senior executive, dot, 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 right? Now, if you talk about customer MDM, still you'll have hierarchy. Let's say you have a company called as Cisco Cloud. Then Cisco Cloud, they will be reporting to something like Cisco. Okay, so Cisco Cloud reporting to Cisco. Now this is a vendor, or you can say it's a contracting company, or it's a subsidiary company of Cisco, right? Now that's again hierarchy. And let's say that Sunil, so Sunil is reporting to, let's say, Cisco. So that is a hierarchy between a person and a company. Okay, and similarly product level hierarchy, let's say like iPhone 7, or let's say iPhone 6s, that reports to, let's say, iPhone 6, that reports to iPhone, that reports to Apple mobiles, and then to Apple electronic products, then finally to Apple company as a whole. Okay, that's the hierarchy in a product. So hierarchy is something that you will see everywhere. It's not a new concept or something. Okay, that's something you'll see, and this is what is configured here. If you want to support hierarchies in MDM, in Informatica MDM, then you have to configure that here. Okay, and then comes SAM. SAM means Security Access Manager. Just 1 minute, I'm getting some message. Okay, now SAM, Security Access Manager, now that's related to administration. It's nothing much to do with development. What this does is, I mean, like, let's say that, very simple case, let's say that Amit has created a base object called as C underscore party, right? Then there's another user called as Altaf, let's say, and Altaf, when he wants to work on that base object, he can't see that, he cannot work. Okay, so now what Amit should do is, Amit should go here in this tool, he should create a role and assign this base object, this party table, to that role, and that role he needs to assign it to the user called as Altaf. Now then Altaf can access that base object. Very simple thing. I mean, this feature is there in almost any tool in the world, database, non-database, everywhere. You have the concept of roles. So that's what it does. The details on how that is done, now that will not discuss now. We'll see that later because that's a separate topic. All right. Now, yeah. So in the data steward, I've explained what is a data steward. Data steward is a user, or it's not exactly user. It's a kind of person who will be a part of your MDM project, and normally he'll be from the business side, and what he will be responsible for is he'll be responsible for the complete project, the data mostly, right? So regarding the manual mergers, how many records will be manual merge, and if the records are duplicates or not, and then updating the data, working with the source teams and all those things. That's the job of data steward, right? And typically data steward will use these three things. Data steward will not use these utilities because he has no technical idea at all. He has no knowledge on what is schema, what is table and all that. He has no idea. So the only tools that are relevant for a data steward is this tool. Okay, in the data steward, whatever you see, that's the tool that's relevant, right? And if you go here, this one, oh, but 1 minute, I'll just quickly tell you what is done here. In data manager, we basically unmerge the records. You understand? Unmerge, reverse of merge. In merge manager, we basically merge the records. So you manually merge the records, right? And in hierarchy manager, you view the hierarchies. So let's say you have hierarchical data like this one, what I was explaining, the iPhone and all that thing. So you can view that here. Batch viewer, batch group are both are used for running the jobs. So batch viewer is used to uh, run the jobs individually. Let's say you want to run a staging job or a load job or particular jobs. Okay, then you can do that. In batch group, you are going to create a group. So this is moreover like a workflow concept. So concept of workflows. So you create a group and then you run that group. Okay, so that's the concept of batch viewer and batch group. And process server, I have already explained that this is also called as the cleanse match server, and this is necessary to execute the jobs. Okay, and the good thing is that you can have multiple process servers allocated to one system, so to fasten things. And audit manager is basically used for auditing inbound outbound operations. So inbound, if you're getting a message, and outbound, if someone is picking something, then all the things can be audited. SIF manager is mainly used for ORS specific SIF APIs, which we'll see later. And user object registry is, you have many things, but we don't use anything except the user exits. That's the most important thing, user exit, which we'll see later. That's the introduction about this tool. Now what I will do is, just give me 1 minute. So we're done with the architecture and to this tool, and then the creation of the ORS. So yeah, we'll see the creation of the ORS. I'm just checking if I missed something. Tool access that I've explained already. Yeah, creation of the ORS will do it because, yeah, but not now. Let's start with the designing of the data model. So let's see the designing of the data model, and then once you understand that, then we'll see how to create an ORS and move ahead. Right.
Hey Sunil,
Yeah.
if I could ask you one quick question. I keep hearing this base object, right? And this could be a dumb question. Could you explain a little bit how do you define a base object, please?
Base object is something that you create here. In the schema, you have base objects, you have landing table, you have staging table. So landing table, base object, and staging table here. So staging table is created inside a base object. To create a base object, it's very simple. You take a log and then you right click, add item here, and give some name, demo, let's say. Okay, that will create the base object.
So how do you define it? Is it a table?
It's a table. It's a
It's a
table.
table? Okay.
It's not a single table. It's a bunch of 11 tables, which I'll explain when I create the base object. When I create the data
All
model, I'll explain that. But it's not a single table. It has its supporting tables. Total 11 tables are associated with this base object.
Okay. All right. Got it. Thank you.
Right. Now let's go through the data model, try to understand. Yeah. Okay. So before jumping into the data model, let's have some discussion. Okay. Data modeling is actually very simple, but you will see in many companies that data model will be a privileged role, privileged role in the sense like people with 10 to 15 years experience, highly talented people would work on data modeling kind of stuff. So it's like a rocket science something. Frankly speaking, it's very simple. It's not easy, difficult. Okay, let's try to understand that. So data model means what? What exactly is that? What exactly it means is, see, I have data, I want to store that in somewhere. Now, if I decide to store it in files, now that's a file model. Like how would I store it? Let's say names, I will store it in one flat file, and I will store the address in another flat file, right? Then there is I would need to join that. Okay, so that is also possible. In Unix you can do that, right? But no one will prefer files, XML file, those kind of things. It's always databases. Why? The most important reason why we use database for everything in IT world is because of this thing, relational. You can have relations, you can create, and very easily you can join things. So because of that, so relational DBMS, right? So when we are talking about, so this is clear why database is the most popular method to store anything, to store any information, data, right? Now if that's the thing, so our MDM data will be storing in a database, right? Now when we are going to store that in a database, the question is 1 minute. Okay, now the question is how. So will I be storing that in a single table, or will I be storing that in multiple tables, right? Now if I store that in very, see, if I explain this in very simple direct technical terms, the, let's say, uh, let's try to take a case, a customer, case of a customer. Let's say customer goes to a Airtel store or a Vodafone store and he applies for a connection. All right, now a lot of information will be generated, now a lot of data will be generated. So 1 minute, can you hear me, right? Because I'm getting a message that can't hear me. 1 minute, you can hear me, can anyone confirm? Okay, fine, that's fine. Right, okay, so a customer, let's say Sunil, he goes to the Vodafone store and he applies for a prepaid connection. Then information will be generated. What kind of information? Information like the details of the customer. So my details, my name, my ID details, my bank account number, those kind of things, right? And my address, that's very important because that's the most important thing, address. Plus another most important thing is the contact, because it's not possible for me to every time send a letter to your address, hard copy. I would rather use electronic world. So contact, normal contact, and electronic contact, important. Plus there will be a lot of other things like your, what will that be, let's say what type of connection you have taken and what is the cost, so what is the price you have paid, and then the quantity sold and all that thing, right? Now, so I need to create an MDM based on this source. So first thing, I have completely clarified that you don't need this information, price, quantity sold, that thing, you don't need that information in MDM. In data warehouse you need that, but not in MDM. So I'm removing that. So it means that even if that is there in the database, you might have a question like, okay, now this information is there in my source system, what to do with that? You don't do anything, you just neglect it. You don't take this information, you take only the necessary information, right? So basically, and then you will have something like your accounts related to this particular person, and let's say you are into the marketing also, then channels, then plus you will have something like relations between the customers, so these kind of things. So my objective is basically, in, see, whatever I'm explaining, this is generic to any MDM project. So in any MDM project, it basically starts with this. So now you know that you need to master this. Plus, if the business is requesting you to master some other information, let's say they would also, let's say there is a concept of something like license uh, in their company. Some term, every company will have one strange term, okay, that you need to understand functionally. Now they want to master this one, so you create a separate entity for that, right? Now the first question is, can I store all of this in a single table? And if I do that, that will be called as a denormalized table. Denormalized. So can I do that in MDM, storing customer, address, contact, account, all of it in a single table? No. What's the problem? The problem is if I do that, it will have somewhere around 1,000 columns, first thing. So the table itself will be very huge, very difficult to access, right? And it will contain redundant or duplicate data. Redundant data. Now that's the denormalized style. So I can't use denormalized, so I must normalize it, right? So if I have to normalize it, let's say earlier I had just a party table, the one table party where I'm storing everything, right? Now normalization is a process where you break down this table into further tables. Why would I do that? I would let's say I'm storing this 1,000 columns here. What I will do is I will break it down into party, address, contact. let's say in party I am storing just uh, 20-30 columns, and in here I'll be storing the remaining columns, and in here the remaining columns. What is the advantage? The advantage is simple. Let's say Sunil, he's living in Texas. Amit, let's say HNO 101 Texas. So you can see that this is getting duplicated unnecessarily. So to prevent that, I am applying the first normalized form, right? And if I apply the second normalized form, you will see that I need to break down the table even more. Why? There will be some redundant data in here. Break it down. If you want further, that's 3 enough, third normalized form. So where you will not have any duplicates in third normalized form, right? But what kind of model we follow normally? We follow as a combination, like some tables will be in 1NF, some tables will be in 2NF. Normally 3NF we don't need, so 2NF. Some tables will be first normalized, some tables will be second normalized form, right? And it's basically an entity relationship data model. Nothing to do with dimension modeling or star snowflake. That's a complete different world. So in this case, if I have to make it very simple, let's say that I don't want to deal with this accounts, channels, relationships, anything, because that's not mandatory. That will depend from project to project. Now in that case, I would create a data model something like this. I have a party table, address table, contact table. Party is the main table, and that's the reason why it will be called as a party data model. Now a very popular thing is, why is it called as party data model? That's a question in every interview. Party data model, and a lot of people are curious, what is the party? It's not that kind of party what you're thinking, but party exactly means, see, let's say that Sunil goes to Bank of America, right? You know what Bank of America will say? They will not say Sunil, they will say that's a party. So party is nothing but a customer, right? Now Sunil goes to Bank of America, he is a party for Bank of America. IBM, let's say IBM goes to Bank of America, he is also a uh, what is IBM for Bank of America? Party. Party means a customer. So both are parties only, but there is a difference. This is like a small party or poor party, so you can say this is like a person, so human being, individual, and this is a corporate, so this is organization. Both are parties only, but the party type is different. So Sunil is a person, IBM is a organization, right? But that's the reason why we call that as party data model. Why? Because uh, the whole model is centered around one table. That's the party table, and you will see that it all started with this, a single table. That's the party table, and all what I'm doing is I'm normalizing that single table, right? Applying different rules. So that's the reason why this is called as a party based data model. And you will see that in 99.99% of projects, the data model that will be used is party data model. Now see, this is only for customer MDM, okay? For customer MDM, it will definitely be a party based data model only. Now, is this thing correct for other MDM tools also, like IBM MDM, Siebel MDM, SAP MDM, Reltio, Kalido, TIBCO MDM, Teradata MDM, right? Will it also be party based data model there? Yes. So that's a very good thing, because if you're switching from one tool to another, you will still not have much to, I mean, you don't have to work really hard, because pretty much most of the things will be same. The data model will of course remain the same, party based data model, right? So as a result, you can see something like this: party, address, contact. That's the most basic data model to start with. right? Now let's try to understand this data model first, and then let's see how to extend this data model to a larger one. So how to, because you can imagine, you can understand this very clearly, that you can't implement this data model in your project. Why? Because this is very small. Now the answer is actually not this is very small. The answer is why. Why means what is a business justification I can't do it. We'll see that. I'll give you 5-6 points why we can't do it. But before that, first let's have full clarity on this data model. Alright, first let's study this page explains this one, the landing table, staging table, base object. Right, now whenever I'm talking about a data model, I'm talking about the base object only. Now why not data model for landing table, and why not something for staging table? You know that landing table and staging table are processing tables. Okay, they are temporary tables. So since it's temporary table, we don't have data model for them. So data model is only there for the base object. Right, now see, speaking about, there is a question like uh, see, I'll make it completely clear. Informatica MDM is multi-domain. First of all, Informatica MDM comes in 3 flavors: MDM, registry, edition. Second is multi-domain edition. The third one is MDM cloud. Okay, MDM registry is like a, what do you say, pocket PC. You have seen something like a pocket PC, right? So it's something like that. It's a very small edition of MDM, which is very limited. The only reason why someone would go for it is because of its cost effectiveness. It's very cheap to implement, and you don't need 10 people to manage that. Just need one guy. So it's very small and simple edition, and this one will come with a data model. It means that, let's say you're running a pharmaceutical company. Now when you want an MDM, you will ask Informatica, they'll give you a pharma MDM. So that's a built, like ready to use product. But talking about multi-domain edition is not specific to any domain. You can implement any domain. So here there is no data model. Why? Because that's multi-domain. You can create your own data model, because if someone is providing you a data model, he will provide you a data model for a specific domain. You understand, right? Because what we are studying here, this one is the data model for customer MDM. For product MDM, it will be different. For employee, it will be different. So I can't sell data model for multi-domain. It's not possible. It's something that you need to do. So that's why there will not be any data model initially. So we need to create our own data model in Informatica, right? But talking about other vendors like IBM MDM and SAP MDM, you will see that typically they provide, the MDM that they provide is very similar to the registry style of MDM in market. Informatica MDM is unique because it's software that provides true multi-domain. So you will see that other vendors like IBM MDM, SAP MDM, they are not true multi-domain. So that's the reason why you will see that IBM MDM and SAP MDM, they will come with a data model. Okay, but the problem is, let's say if you want to go multi-domain, that's a headache with these tools. It's very difficult to stretch, and you need to purchase separate products. Okay, so let's say you have like Siebel. So Siebel will come with UCM, Universal Customer Master. Then Siebel comes with a product MDM also. So for every domain they have a specific product. Now that's not the case with Informatica. So it's like I'll sell you the wheat. So you want to make burger, pizza, whatever you want, you can make it. It's like that. So this is something that we have to build. We'll see that. That's why I'm explaining data modeling. Right. Now let's study the columns. Let's try to finish this, then we'll move ahead into something. We'll see the disadvantages of this and how to improve that. Right. Now party table. I have, this is a very small table, and the the most important table, of course. I have name, organization name, status, party type. Here you see status, alias and all that. Just neglect that. I need to update it. So name is nothing but the name of the customer. Alright. Now I have decided to store both person and companies, or you can say individual poor guys as well as corporates, the rich companies. I'm storing both the information, both types of customer in the single table. Now when I'm storing both the type in a single table, like let's say that I am storing cat and lion both in a single zoo, then I must differentiate, and that differentiation is using this something called as party type column, that is this column. Okay, so the party type will be person for this, organization for companies, and one man shop is a concept where it's neither a person nor a organization. It means, like, let's say that in US, you know that in US and Europe, both the places, uh, most of the, what you say, it's most of the businesses are monopolized. For example, you will see that uh, in India you will see grocery stores, many millions of grocery stores. In most of the advanced countries you will not see, because that industry has been monopolized. So you will either see a poor person or you see a very huge guy. That's a company, like very big company like Microsoft, which is like monopolize almost everything related to OS, right? But one man shop is a concept where it's like a person only. Let's say husband and wife, they are operating the store, just husband wife, they can't hire anyone else. So it's just either one person or two persons, they are maintaining the very small business store. So they can't be person, they can't be a company, because that's not a company. So that's one man shop. And you can also create separate categories based on your business needs, right? Or you can categorize based on scale also, let's say small scale, large scale, those kind of things as well. And then the status of this customer, active, inactive, pending, deleted, those kind of thing, right? And if I'm trying to insert Sunil's detail, I will insert the name here, but organization name I'll keep it blank. Why? Because Sunil is a person, so organization name is blank. Now when I try to insert IBM's detail, then name will be blank for IBM, organization name will be filled with IBM. That's the key concept. And remaining things, this will be organization, right? Now you see something called as row ID object. What is that row ID object? Row ID object is a system generated column. It means that if I go here and let's say I go here and create a table called as demo. Okay, see, I'm creating this table from scratch. So I just go here, click on columns. Now when I go and do that, you can see that I have an uninvited guest already. So I have a column that is already created. I have not created that. Now that's the row ID object. It's a system column. What is the use of that? The the use of I'm getting some. I am muting. Yeah. So it's a system column. The use is this will serve as the primary key for every base object. So you might have this base object, you might have this one, you might have this one, you might have 20, 30, 40 base objects. So for every base object, the primary key is row ID object, right? And if that's the primary key, who will insert values into that? Will I insert values in this row ID object? No. This is more over like a surrogate key or an artificial key or a replacement key, or you can say like surrogate key. That's the most popular thing. So this is generated by the system. Informatica will use a sequence. Informatica will use a sequence that the value will start with 1 and it will increment by 1. So if you insert 10 customers, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? You don't have to insert any value to this row ID object. Informatica will automatically take care. All what you are going to do is insert data into here in these columns. Right? And you will see that you will also have row ID object for address, row ID object for contact. Right? Now the question is, you see row ID object here, you see row ID object here. The name is same. Are they same? The name is same, that's correct. But apart from that, I mean, the values are the same? No. So they are completely different. This row ID object has nothing to do with this row ID object. They're completely different. They have different purpose. Now let's study this address table. I have something called as the ADTR underscore name. That's the complete address. Complete address in the sense your house number, street number, state, city, country, postal code, those kind of things. Right? Now address name is actually combination of line 1 and line 2. So if you concatenate line 1 and line 2, that is nothing but your address name, the full address. Alright, and then the state, city, country, postal code, address type. Okay, now this what is this? Is this something rocket science? No. Like when you order something from Amazon, or let's say any common thing, you will give these details. So that's the same thing here, and that will be the same thing in any MDM project, because address is address. Right? Now this is clear. This is clear. What is this? Party ID. Party ID is a foreign key. It means you see here that from party, you can see in this data model that you have party, you have address, you have contact, and you do see something like there is a relationship between them. They are related. Now if they are related, they must be related with a key, right? So that's what is this is the relation. So the party ID in the address table is equal to or related to the row ID object from the party table. It means that this is nothing but it's a foreign key, and it is pointing to the row ID object here. Right? That is the relationship between this address and contact, and that's what this party ID is. This party ID is nothing but the foreign key. Okay, and then row ID object here, and see, and in the contacts I have the row ID object that is nothing but the primary key, and then the party ID which is related to the party using this relationship, and then you have the contacts. Right? Just 1 minute. Okay, now initials, first name, middle name, last name, gender, phone number, email ID, fax number, date of birth. I don't think I need to explain this because I think you know. So initials is init cap, like SKM. So SKM, and gender, phone number. So this is the most common thing that anyone will store. Right? That's the base object definition. Then if I go here and check the staging table, in the staging table you can see the name, organization name, status, party type, PKSRC object. So you can see that the staging table is quite similar to that of the base object. At least I can see that. It's quite similar, except the PKSRC object, it's pretty much the same. So first question, does it should it be like that always? Will it be like that, like this will be same, or will it be different? See, it is mandatory that the structure of the staging table and the structure of the base object should be in sync. Why? Just see why. For example, this is my base object and my staging table, this is my staging table. Okay, now when I want to create a staging table, how do I create a staging table? Right click, add staging table. Okay, and when I do that, it will show me some columns. So it shows me certain columns, right? These columns, from where it is getting the columns. It is getting the columns from the base object, right? So these columns are created in the base object. So it means that I can either select all of it or I can select just only this much. So whatever it is, the structure of the staging table will always be like a subset or similar to that of the base object. It's mandatory, right? So that's why you can see something like this. You will see this an additional column, that is PKSRC object. And what is that exactly? PKSRC object is nothing but it is a primary key from the source, or you can say it's the source key, right? That's the source key. And you have something like a landing table. Landing table is nothing but the first table, and the structure of the landing table, you can see that this is also similar to that of the staging table and the base object. Now the question, is it mandatory that the landing table structure should be similar to that of the base object? No, it's not mandatory. It's not necessary that the structure of landing should be similar to that of the base object. Why? Because we have a mapping. You can have 1,000 columns in a landing table, but just 10 columns in a base object and staging table. Is it possible? Yes, possible. But if that is the case, then why I am having similar structure? And see, I am having the structure, the similar structure, because normally that will be the case in any project. And why is that? That will be because we want to simplify things in MDM. You understand? If I have 1,000 columns in landing table and 10 columns in staging table, then I need to really worry about mapping, joining this, that, pulling data, doing that. Now I don't want that kind of headache in my MDM. If I don't want that headache, I have to give that headache to someone, and I would like to give that to the ETL guys. So what I want is, I want the ETL guys to understand the data and then use the mappings, joins, all those things, and then convert the data to a specific format, and that's this format, right? So this is just for the sake of simplicity. I've synchronized the structures, but it's technically not mandatory. But normally you will see in most of the projects it will be like this only, right? So that completes this page. We also have something called as lookup translation, which I'll explain later what is lookup translation, because slightly advanced. Right, now let's try to understand the disadvantages, or not disadvantages, it's drawbacks. Drawbacks of this data model. So if I have to understand this one, the drawback of this data model, then let's pinpoint one by one what I can see here. First thing, what I can see here is it's limited entities, or you can say in technical, it's nothing but tables, limited tables. In the sense, why limited I'm saying, because account, channels, then party rel, then organization, extension, dot dot dot. All these tables are not supported in this data model, small one. So that's one limitation. Second, limited attributes, or you can say columns, nothing but columns. It means that I'm storing the contact, but where is the Twitter link, where is the LinkedIn, where is the Facebook, and those kind of things. I'm not storing that, right? So limited attributes I'm storing, right? Third one, the many to many is not supported in this data model. Many to many is not supported. I'll explain that what is many to many. And hierarchy is not supported. Can you tell me, like, if there is a relationship between Sunil and IBM, so is it possible to explain that relationship using this data model? No, not possible. You can store Sunil and IBM, that's correct, but you can't describe the relationship. Okay, that's a limitation. And if I check further, then reference tables are missing. In any data model, it's important that you have reference tables. I'll talk about that. So that is also again missing. And I think that's it. Maybe if something comes into my mind, then we'll see, right? But let's concentrate on this one. So I have these issues in this small data model. So if I tackle these issues, then I can implement this data model in a real-time project, or in your company you can implement. So let's try to tackle that, right? So first thing, limited entry rates. It means that account channels, party rel, organization extension, and dot dot dot. I mean dot means table specific to your company. So if your company is saying that, okay, we want this kind of table like license, or we want this table, we also want that table. So you put down all those things, right? As a result of that, you can see here that some of the tables I have tackled here, like the account. So earlier the account was not there. Now you can see the account table, party table, account table, right? And party rel table is still not there because that's related to hierarchy. Organization extension table, you can see here, organization extension table. What does it do? It's a table that specifies the more, like it provides more details on companies. So for Sunil, will you see an entry here? No. For IBM, yes, I'll see an entry here. So I'll see the party ID, the business type, what type of business it's doing, annual sales amount. It's not a measure. If you want to measure something, you can measure it, but the reason why I'm storing annual sales amount, just to provide an estimate, okay, this is a big company because their sales amount is very huge, right? Similarly, employee count and all those things. Legal entity seat code. So like every company will be categorized into a particular legal entity type CD. Categorization of companies. That's what it is. Okay, and that's what is tackled here. And then limited attributes. You can see my contact table had quite limited information, just limited things. Now that is uh, rectified here. So you can see the first name, middle name, last name, criminal status, ethnicity type, death date, also alive status, and income code, birth date. Pretty much almost all the things that you can store are here. So now see, there's no limitation on that. It means that when you are doing it, you can apply this rule on any of the table. Let's say address, you want to store 50 columns, you can do that. No one else will stop you from doing that. Okay, but the thing is, always try to create something because it's necessary. Don't uh, create a column or something just because you have seen somewhere in some data model. You only implement it, create it if you need that, right? Then many to many was not supported here. It means that if I go and check it here, then the relationship between party address party contact is, what is this relationship? This is actually 0 to many, and for sake of simplicity I'll just say it is 1 to many, right? So why am I saying it's 1 to many? You can see here, this signifies this is the parent and this is the child, and this is 1, this is many, so that's 1 to many. Here also it's 1 to many, right? Now I might have this 4 different type of things, like I might have 1 to 1, 1 to many, many to 1, many to many. I might have these types of relationships, right? Out of which this data model that you're seeing here, this one will support 1 to 1, 1 to many, many to many, but it's not possible to implement many to many. Why? Because normally if you want to implement many to many, it's not possible to do it using just 2 tables. You have to use one more table in between if you want to implement many to many, right? It's mandatory. There's no way out of that. And you might have a question like, why is it that the default relationship is 1 to many? Or if you don't know what is the default relationship in a database, it is 1 to many. Or you can say more precisely 0 to many, right? So why is it like that? That's how it is. In a real world also you will see it's 1 to many. One parent can have multiple children. So something like that. If you want to change that, you can change it. So that's what we are trying to do. So many to many means, first let's try to understand why do we need many to many. So let's say 101 Sunil, right, and 908 Texas, right? First 1 to 1. It means, is it possible that Sunil should have only one address? No. I mean, why will Sunil have only one address? He can have a office address, residential address. He can have a different shipping address, different billing address. He can have 2 places, 2 homes. Possible, right? So 1 to 1 is not uh, preferable, right? Now talking about 1 to many, is it possible that uh, Sunil has 2 addresses? Yes, it is possible, but the address type must be different. So if this is like the main address, this can be your post bus address or residential address, something like that. Only one active address is allowed. You can't have more than one active address, right? But anyway, if you see it means yes, multiple addresses are allowed. Now, is this possible? Is it possible that Sunil and Amit are pointing to the same address, Texas, let's say? Sunil and Amit are pointing to the same, they are both pointing to the same address, that is Texas. Is it possible? Yes, possible, because it's possible that multiple people can reside in a single place. And mostly, let's say that if I'm giving my office address, it's possible that 300 400 people will be pointing to one address. Okay, so that's fine, not a problem. So this one both are possible. Now that makes it many to many. So one guy can have multiple addresses and one address can have multiple guys, right? So is it fine many to many? Yes, that's what is that's the correct thing, many to many. Now see, don't think that many to many uh, will be for every data model. See, for example, if I go here, now can I make the contact as many to many? See here, so the contact is what? 1 to many. It means, can I have multiple phone numbers? Yes. Now is it possible that I have this number and this number is allocated to Amit and this number is also allocated to Sunil? Is it possible? That's impossible. That's wrong. So many to many only for address, not for contact. Similarly, you have to find out if many to many is necessary for account, you make it many to many. But how to make it many to many? See here. You have party table, you have address table. Instead of directly linking, I'm not directly linking here. What I'm doing is I'm using an intersection table, that is this table, party address table, and I'm joining using that, this intersection table, right? And and if you see here, uh, it's very simple. See, what I'm doing here is in this table, this party ADTR table, I have two columns, party ID, I have address ID, party ID and ADTR ID, right? What is party ID? Party ID is nothing but the row ID object of the party table. What is address ID? It is the row ID object of the address table. Just neglect this one, neglect this party ID. Okay, this is for a different use. So you can see this is a very simple table, right? Just the primary key it is storing. So how is this many to many? See here, party to party ADTR, it is one to many, right? And address to party ADTR, it is again one to many. So if I do a virtual join between address and party, virtually if I try to join these two things, then the relationship will be many to many. So that's how it is, many to many. If you still have doubt, you can try to create some data and try to visualize how it becomes many to many, right? And next point, then hierarchy is not supported. Yeah, hierarchy is still not supported in this data model because I don't want to complicate things. Hierarchy we'll see later. So how to support hierarchy? We have to add additional tables, that's the relationship tables, so that we'll see later. And reference tables was missing earlier, now you will see reference tables. So this is nothing but it's a reference table. So wherever you see something like lu underscore, that's a reference table. Anywhere wherever you see lu underscore, that's a reference table. For example, what is reference data? It's very simple. See here, address. Let's say that you are doing business only in US and Canada. You're doing business in just US and Canada. So your addresses will be American and Canadian addresses. You will not have an Indian address in there, right? That's what will be there in the address table. But in my country table, what will be there? My country table will contain list of all the valid values. So this will contain 240 countries. 240 countries. Now that is the difference between data and reference data. Reference data is used for reference, right? Another example, let's say in contacts, you're dealing with just say married people, just married, bachelors not allowed, let's say married people. So here you will have only married, status as married, but here you will have married, unmarried, soon to be married, divorced, soon to be divorced, dot dot dot, all statuses will be there in this lookup table. So lookup is nothing but list of all the possible values. Why is it important? It is important to make sure that, see, let's say that you the name of the country is USA. If I try to insert something like this, it will not allow me. Why? Because in the referential this is not there. So reference provides a list of valid values that can be used. So that's why reference tables are important in any database, sorry, in any data model. So that's what we see here. And technically speaking, reference tables and base objects are the same thing only. Same thing in the sense, I mean, see, you see here. So to create a base object or reference table, The method is the same. You right click and say give the name and create it. It's the same. The only thing is, in case of a reference table, there is a special button that is lookup indicator. You just need to select that. And in case of a normal table, don't select that. That's the only thing. Otherwise, it's pretty much the same, right? And okay, so then that completes this one. What you do is you go through this thing, then you'll get a bit more idea on this. That is like what is this ethnicity type and employment status, those kind of things. Okay, go through this complete thing, the legal entity type and account type and those, right? Now we have something called as ORS underscore sample, where you will see a different this data model, which is slightly bigger, and it's an enhancement to uh, this model that you're seeing here. But what I'll do is, what you do is later you go and check this data model. Actually, the normal server that we are using, it's there is some problem with this server, so I'm using an alternate server. After the session is done, I have to fix that. So what you do is you go to ORS sample later. Once it is fixed, then you check the data model there, and that data model is nothing but this one, which you can also see it here. In books you will see something called as resource kit guide. Okay, resource kit guide, I think. No, not this one. Yeah, sample ORS configuration guide. In this guide, if you open it, then this data model is explained clearly. Okay, so this data model with all the source systems, then the see here, the data model, whatever you're seeing here, it's the same thing that you're seeing here. Okay, this data model. So you go through this, and tomorrow I'll explain you about this data model, right? Okay, I think I will finish the session today. If you have any doubts or anything, then you can ask.
Yeah, so, can you send me those documents to? Can you put it in those documents in the shared drive and
Yeah,
I did not get it anything.
you send me your mail ID.
Okay, I'll
Okay.
ping you
Yeah, you
in the
can.
chat.
Okay. Yeah, okay guys, if you have any more doubts, anything, then you can ask. Okay.
So,
Yeah, Naveen.
so the access is the same thing, right?
Yeah,
As
it's
if
the
you're
same
using
thing what you have earlier, whatever you were accessing, it's the same thing.
so the recordings will be different, right? What you will
Okay, I've
see.
not shared with you. Okay, I'll share, no problem.
So can you share me so that
Sure, okay, I'll do that.
okay, thank you.
Okay, thanks. Okay, thanks guys. Then you go through the documents, PPTs also. We'll discuss tomorrow. Okay, regarding this data model. Thanks.
Okay, thanks, Sunil.
Thanks.